All right, welcome to chapter 4, day 8, I believe. Yes, day 8. And we are looking at different types of experiments. Okay, so let's talk for a minute on the 3 types of experiments, experimental designs you can have. There are 3. One, you can have what's called a completely randomized design. A completely randomized design is when you assume or are told that all of the subjects or volunteers that you have to work with are essentially the same. Because the objective in any experiment is to have groups that are all basically the same. They have the same number of different types of people, or they all have the same types of people or subjects. And then the only difference is the treatments that you're imposing. Well, a completely randomized design, if you are given 100 identical rats that are exactly the same, then no matter how you randomly split them up, the groups will basically be the same. For people, completely randomized is harder, but you might get a situation where you get 100 males that are all the same weight and same age and are trying to work out with a trainer and get stronger. You might get lucky and get a group like that's all the same. Or you could recruit a group that's all the same. Okay? But it's a little more rare with people. It's a little more common to do completely randomized designs with animals that you can get all the same, something like that. Okay? All right. A block design is when you have different groups within your volunteers or your subjects, okay? So a block design could be at a high school, if you have freshmen, sophomores, juniors, and seniors, we may want to block them and separate them equally, okay? You might have girls and boys in an experiment, and then you have to put the girls in 2 groups and the boys in 2 groups, or 3 groups, or 4 groups, however many you have. But blocks are picked by the experimenter. Randomization then splits up the blocks into the treatment groups equally. Okay? And then the last type of experiment would be a matched pair design, where you are doing something twice, an object is doing something twice, or 2 people that are almost identical are split up. For example, if you're doing a experiment on blood pressure medicine, you might get 2 people that have the exact same blood pressure. One gets the medicine, one gets a placebo. That's a matched pair. Okay? So the 3 types of experimental designs are 1, completely randomized, 2, block design, and 3, matched pair. Your job as a student is to pick the best design that controls the most variables using common sense. All right, so let's look at this. Let me read the problem to you. A preliminary study at the Medical Center in St. Louis has shown that treatment with small, low-intensity magnets reduces the self-reported level of pain in polio patients. All right, fine. During each session, a patient rested on an examining table in the doctor's office while the magnets embedded in soft pads were strapped to the body at the site of the pain. Sessions continued for several weeks, after which pain reduction was measured. How do you measure pain reduction? It's probably self-reported. So just so you know how they get that stat. A new study is being designed to investigate whether magnets also reduce pain in patients suffering from herniated discs. 100 male patients are available for the study. 100 males. They might be volunteers. Volunteers are not bad. Volunteer response is usually biased, but you often need volunteers for experiments. Design a completely randomized design. So this question makes the assumption that all these male patients are the same, probably in the level of pain they're suffering. They have self-reported probably the same amount of pain. Because in order to do a completely randomized design, we have to assume that the subjects are the same in the area that we're measuring. So I'm guessing the self-reported pain is the same for all 100 patients. Okay. When they ask you to design something, you can write it out in paragraph form, you can write it out in bullet form, or you can draw a picture, an algorithm, which is often what I do. So I usually draw squares around things to show you how things are moving. So this is a group of 100 patients, and we are measuring you measure their pain level to begin with. Then we got to say random allocation. 50 patients use the magnets. I don't know how long. It doesn't really say how long. I'm going to go ahead and draw arrows here. And 50 patients without magnets, okay? Does this say 4 weeks? Maybe I just made that up. After 4 weeks, reevaluate the pain levels and measure and compare results. That is a very simple, completely randomized design. These two groups should be equal because, in theory, everybody out of 100 had the exact same pain level that they were managing. They were all 9s out of 10s. So that when you split them up randomly, these should be the same groups in terms of pain, and the only difference is one gets magnets and one doesn't. Okay? So that's a completely randomized design. All right. Now, question B says, describe how you would modify the study if there were 50 males and 50 females in the study. All right, if there were 50 males and 50 females, I would do a block design. I would block by gender. Although you could block by pain level too. It's not like you have to do gender, but this problem just kind of leans itself that way. But you could block by pain level, okay? So I'm gonna put a square around the group, 100 people. We're blocking by gender, okay? Blocks, you choose the blocks. Blocks are not randomly done, you choose them. Now we have random allocation, and 25 get the magnets. I'll put the arrow all the way over, and 25 males get the magnets. And then for the females, same thing, we randomly allocate these. Half get magnets and half don't. And then after 4 weeks, we'll reevaluate the pain. If you notice, in theory, these two groups should be the same, and these two groups should be the same. So those that got magnets, there were 25 that got magnets from females and 25 that got magnets from males. And of course, the ones that didn't get magnets were also 25 and 25. So we have equal groups in the end to compare. We have 50 people in each group, 25 males and 25 females. That is called a block design. You just have to make sure that you block on the right variable. In this case, we thought it was gender because maybe males and females handle back pain differently. I don't know if they do or not, but maybe they do, okay? I could have also blocked on high pain, low pain, and not worried about gender if I thought the magnets might work differently with low pain or high pain. That's another area I could have blocked on, okay? All right. Now, we have covered completely randomized and a block design. And at any time, pause the video and make sure you copy this down and get it all dialed in on your notes, okay? This last question, I'm going to read it here first, okay? Waterproofing boots. A manufacturer of boots plans to conduct an experiment to compare a new method of waterproofing to the current method. The appearance of the boots is not changed by either method. The company recruits 100 volunteers in Seattle, where it rains a lot. Okay, fine. To wear the boots as they normally would for 6 months. At the end of 6 months, the boots will be returned to the company to be evaluated for water damage. All right, we got 100 volunteers. So I guess we have 200 shoes overall, correct? Because 100, they all have 2 feet, I'm assuming, okay? And it's raining in Seattle a lot. And we are going to compare the new waterproofing to the old method. Okay? Now, what's the best way to do this? Let's think about it. Let's say we did a completely randomized design, and we assumed that all 100 people would be in the rain the same amount. Okay, if we did that, then we would randomly flip a coin, and half, or do some sort of randomization, half would get the new waterproofing, half would get the old waterproofing. I have zero confidence that those two groups would be in the rain the same amount. I don't think we have controlled that variable very well. So I don't think a completely randomized design is a very good idea. Okay, let's do match pair. Well, actually, let's do block design first. Let's block this. All right, let's say we get 50 people that they say they're going to be in the rain a lot, and 50 people that say they're going to be rain very, very little. And we have those two blocks. 50 in a lot of rain, 50 in little rain. Fine. Then what we're going to do is we're going to randomly assign 25 people from each group to wear the boots a lot. And then we're going to compare them later. I still don't think that it's controlled the variable the best. The most clever way to do this is to do a matched pair design where your 2 feet are the pair. If you think about it, your right foot and your left foot are very likely to have the same amount of rain happening. So this is brilliant, where we could do a matched pair design where the individual's feet are the matched pair. So that's what I've done here. Okay? So this was a question on the AP test many years ago, and the people that did a completely randomized or a block design got a partial credit. They didn't get much credit for it, okay? This is what you should do. Now, I like to do my matched pairs out with bullet points. Just explain things, okay? 100 people self-paired, both old and new. Randomly assign 50 to use the new treatment on the left foot, old on the right, and the other 50 new on the right and old on the left. I would write left and right out in more words than that. This is just my notes, okay? I would wear or use them for 6 months, and then later I would compare the results. This matched pair design is the right design to control the most variables. And that's what you have to think about. 3 designs: matched pair, block, completely randomized. That's your choices you have to make. Okay, could your design be double blind? What does double blind mean? Double blind means 2 things. It means the subjects don't know which foot has which wear guard on it, and the evaluator at the end that holds the 2 boots up and says, this one is better than this one. That evaluator should also be blind as to which one's which. This doesn't mean that nobody knows. There's a clerk who wrote down who has which wear guard or waterproofing on which foot. Somebody wrote it down. It's not like they don't know. It's just the subjects don't know and the person evaluating doesn't know. When do you do double blind? You do double blind when the evaluation process is subjective. When it's subjective, you need that evaluator to not know, because otherwise he may skew the data. Okay? All right. And I wrote this out really minimally. Yes, you got to mention the evaluator and subject, and it's an opinion based in the answer. So you got to explain that a little bit. Yes, this could be double blind. The subjects don't need to know which waterproofing is on which boot, and the evaluator should not know which waterproofing is on which boot because the evaluation method is subjective. That would be a great answer. All right, hope you enjoyed it.